Dan yang berbahagia, Profesor Datuk Teknologis Dr. Masila Binti Kamarudin dan Div-Div Kehormat, hadirin dimohon berdiri. Para hadirin diminta terus berdiri bagi sama-sama menyanyikan lagu Negaraku dan UTM terbilang. Hadirin dipersilakan duduk. Kepekan Kuala membeli bingka burung merba di pohon cemara. Majlis bermula, tirai dibuka. Assalamualaikum, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia, Profesor Datuk Teknologis Dr. Masila binti Kamarudin, Naib Chancellor Universiti Teknikal Malaysia Melaka. Yang berusaha, Profesor Dr. Zulkifli bin Ibrahim, Timbalan Naib Chancellor Akademik dan Antarabangsa. Yang berusaha, Profesor Insinyur Teknologis Dr. Ghazali bin Umar, Timbalan Naib Chancellor Pendidikan dan Inovasi. Yang berbahagia, Profesor Madya Datuk Dr. Sabri bin Muhammad Sharif, Timbalan Naib Chancellor Haliwa Pelajar dan Alumni. Yang berusaha, Profesor Insinyur Dr. Hambali Arif, Dekan Fakulti Teknologi dan Kejuruteraan Industri dan Pembuatan. Yang diraihkan, Profesor Insinyur Teknologis Dr. Sivarao Subramanian, Fakulti Teknologi dan Kejuruteraan Industri dan Pembuatan, Pegawai Kanan UTM, barisan pensyarah, staf dan hadirin yang dimuliakan. Selamat datang ke Majlis Syarahan Perdana Profesor Insinyur Teknologis Dr. Sivarao Subramanian. Hadirin yang dimuliakan, bagi memberkati majlis kita pada pagi ini, marilah kita sama-sama menandatangan mengaminkan bacaan doa yang akan dibacakan oleh Profesor Madya Dr. Lokman bin Abdullah. Silakan.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin, Sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Allahumma salli ala Sayyidina Muhammad wa ala alihi wa sahbihi wa barik wa sallim. Segala puji-pujian untukmu ya Allah, Tuhan sekalian alam, Tuhan yang memiliki segala keagungan dan kebesaran. Selawat dan salam ke atas junjungan besar Nabi Muhammad sallallahu alaihi wasallam, juga ke atas keluarganya, para sahabatnya dan mereka yang mencontohinya hingga hari kiamat. Allahu ya Rahman ya Rahim. Di hari yang penuh keberkatan ini, bersempena dengan Majlis Syarahan Perdana Profesor Insinyur Teknologis Dr. Sivarao Subramanian, Fakulti Teknologi dan Kejuruteraan Industri dan Pembuatan, kami menadah kedua belah tangan serta memuji dan bersyukur kehadratmu di atas nikmat limpah kurniaanmu yang tidak terhingga ke atas kami, sehingga kami dapat berkumpul dan merapatkan hubungan silaturahim, perpaduan dan kasih sayang antar kami. Ya Allah, kurniakanlah kepada kami kehidupan yang aman, damai dan harmoni, serta jadikanlah majlis kami ini majlis yang sentiasa diredai dan dirahmati oleh-Mu ya Allah. Allah ya Hadi ya Muhtadi, kurniakanlah kami dengan taufik dan hidayah-Mu untuk membimbing kami ke arah kejayaan, keamanan dan kesejahteraan di dalam kehidupan kami sebagai warga UTM, dalam membangun modal insan yang berkualiti dan memenuhi aspirasi negara. Jadikanlah kami orang yang sentiasa bertakwa kepadamu, sentiasa mematuhi segala perintah-Mu dan menjauhi segala larangan-Mu. Allahu ya Hannan ya Mannan, berikanlah kami kekuatan dan keyakinan serta tingkatkanlah iltizam kami agar segala ilmu yang kami perolehi dapat kami curahkan sebaik-baiknya dengan penuh amanah, jujur dan dedikasi. Dan jadikanlah segala amalan kami ini amalan yang ikhlas dan bersungguh-sungguh kerana-Mu ya Allah. Allahu ya Fattah ya Karim, kami menadah tangan memohon kepadamu ya Allah untuk kedua ibu bapa kami yang telah menjaga, membesarkan dan mendidik kami ke jalan yang diredai oleh-Mu. Ya Allah, kurniakanlah kami nikmat, rahmat dan kesihatan sepanjang hayat mereka. Bebaskanlah mereka daripada azab siksa kubur dan kesengsaraan neraka, dan himpunkanlah mereka bersama para awliya, syuhada dan anbiya. Allahu ya Sattar ya Alim, kepadamu ya Allah kami pohonkan keselamatan dan kesejahteraan kami. Tanamkanlah di hati kami sifat sabar, cekal dan tabah dalam menghadapi ujian dan dugaan yang mendatang. Hindarkanlah dari kami sifat negatif yang boleh menjejaskan perpaduan, kestabilan dan keharmonian yang selama ini kami kecapi. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wa sallim. Walhamdulillahi rabbil alamin.
Amin, amin, ya rabbal alamin. Majlis merakamkan setinggi-tinggi penghargaan di atas bacaan doa itu tadi. Seterusnya, majlis mempersilakan Yang Berbahagia Profesor Datuk Teknologis Dr. Masila binti Kamarudin, Naib Chancellor UTM bagi menyampaikan ucapan perasmian. Dipersilakan.
Bismillahirrahmanirrahim. Yang Berusaha Profesor Dr. Zulkifli bin Ibrahim, Timbalan Chancellor Akademi dan Antarabangsa, Yang Berusaha Profesor IRTS Dr. Ghazali Omar, Timbalan Naib Chancellor Pendidikan dan Inovasi, Yang Berbahagia Profesor Madya Datuk Dr. Sabri bin Muhammad Sharif, Timbalan Naib Chancellor Haiwan Pelajar dan Alumni, Yang Berusaha Profesor IRTS Dr. Hambali bin Arif, Dekan Fakulti Teknologi Kejuruteraan Industri dan Pembuatan, yang diraikan Profesor IRTS Dr. Sivarao, Profesor di Fakulti Teknologi dan Kejuruteraan Industri dan Pembuatan, Pegawai-pegawai kanan universiti, Akademi UTM, para pelajar, tuan-tuan dan hadirin dan hadirat sekalian. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Madani, salam Melakaku Maju Jaya. Rakyat bahagia menggambit dunia, bijak laksana tua, berani laksana jebat. Salam UTM ku sayang, menjajar universiti, melonjak ke hadapan. Sihat semua? Saya tengok sikit sangat dewan ni. Tu dewan ni besar sangat. Saya assume lecturer FTK IP ni ada kelas lah. Tapi next time Prof Mali kena make sure lah semua datang, hadir, bagi support pada kawan kita. Sebab next time, in the nearest future, one of us pun akan duduk atas pentas ni, give a talk also. So you imagine if no one is watching us, is giving support to us. Betul tak? So ramai lagi profesor, saya rasa yang belum lagi buat professorial talk. So it's good lah pada I untuk start this venture as soon as possible. Maksud saya cepatkan. Sebab saya tengok setahun, 1, 2, kenalah selalu. At least pada I galakkan buat professorial talk. This one I'm talking to MPU. Siapa kat MPU? Waris ada. Pengurus MPU dia, Profesor Zaril, you need to support. MPU need to support professorial talk. This is one thing. Saya tak nak lah ucapan macam saya nak belitih pula kan. Tapi this is the way forward. MPU needs to coordinate this event actually. Prof is here. Correct not, Prof? And because we need to be proud, we are one of the professor in UTM. If you yourself not proud to be a professor in UTM, how other people wants to be proud of you? So are you just like what is being highlight by outside now, Profesor Kangkung? Sekarang semua tengah highlight isu tu kan, Profesor Kangkung, Profesor universiti ni buat paper saja, tak ada tak ada orang kata sumbangan kepada masyarakat, tak tahu apa dia buat. We are not of that. So where the avenue to demonstrate that we are not one of it is here. So today, Prof. Sivarao, congratulations, you made it. And you prove that you are one of the professors, because we need to be professed in our area in order to be a professor. Because most of the question when we enter the interview, we will ask the candidates, what are you professed in? So if today I could see you are in the driving, right, the automotive, mechanical. So which area of that is your experts? Yang ini yang selalu ada masalah bila candidates kita masuk interview. Previously tak boleh nak demonstrate, tak boleh nak spell out. So all the PMs, all the doctors, even all the senior lecturers, you must start from now to identify what are you good in and what you should be professed in. So when people ask you, PM Dr. Siti Hajar, what is your name? Material. I'm biomaterial ke apa ke, material nano ke, something like that. So because bila kita perlukan expert dekat luar yang on that area, I know where to pick, you know. Like I know program is EV, for example. So I can talk about EV because I have an expert in EV. Like Sivarao today, I know he do something about tire. So now if you are talking about RISDA, collaborating with RISDA on latex, in maybe Myros. So all these candidates, all these professors needs to be front to show that we have all this expertise. So I really hope lepas ni TNCA also will take serious together with MPU. Lagi sekali saya cakap, MPU needs to show your credibility and capacity to all the researchers, to all the academics. Barulah kita rasa MPU ni okey. Boleh Waris? Tolong cakap dalam venue. Memang saya tak sempat pergi meeting MPU banyak kali, clash dengan meeting saya. Tapi saya harap perkasakan, empower the MPU. If today punya event pun the pengurusi tak boleh hadir, this is something is not good. So how does the young academics nak work together with us, the professors? Dan satu yang semua kena yang ada ni, yang bagusnya UTM ni, kita akan ada ramai profesor muda. So you all kena be confident, and then you must be brave, you must be bold, and stand tall. Jangan takut-takut. Muda pun kita boleh jadi profesor. Dan satu beauty of Warren Academics, kita tak perlu tunggu umur 60-an, 50-an untuk jadi profesor. If you are good enough, you prove that you are professed in any area, you can go for it. So it's a laluan terbuka. So kalau yang dah senior tak nak grab, yang muda janganlah tunggu, you kena work. Dan yang dah senior pun janganlah kata macam profesor ni nak pencen dapat profesor, mesti dapat profesor. Tak, dah berlaku. Saya pada era saya tak benarkan itu berlaku. You must go with the professors which you are good in. Kalau you deserve, you get it. Bukan sebab you tunggu you nak pencen, you dapat prof. You kena tukar. Kita academics, kita bukan macam tu. Tapi of course lah, dalam untuk kita menjadi seorang professor, to prove Prof Siva today, there's a level of maturity that you have to go through. There are a lot of learning process that you have to go through. There are many life cycles of research, innovations, teaching and learning you have to go through. So as academics, there is no such thing as saya nak buat mengajar je, saya nak buat research je. Yang dah buat research pula tak nak mengajar, tak boleh. That's why kita punya Warren ni special. But we need to do all the 7 P's, all the 5 P's. Mana banyak P's lah, sekarang ni dah tambah-tambah P lagi. Memang you kena buat. Tulis buku pun you kena buat. Dan insyaAllah in the nearest future, sebab government pun dah, ministry dah minta kita tengok kriteria kenaikan pangkat, especially ke profesor, kena ada terbitan buku. Terbitan buku dan ditulis dalam bahasa Melayu. So yang ini MPU pun saya harap akan pick up. So, dan tulis dalam buku bahasa Melayu itu bukannya karya kreatif, karya kanak-kanak, bukan Karya ilmiah means what you are professed in, what is the area that you expert in. You kena ada buku yang you tulis. So, saya baru dapat surat 2 minggu lepas rasanya mereka melihat kepada kriteria itu. Ada tak you can consider on that matter. So, I think this matter need to be discussed further. Untuk semua orang dapat naik pangkat dan you boleh bersedia lah. Kalau you dah 5 tahun nak naik, dari sekarang tulis lah. Slow-slow lepas 2 tahun dapat buku. Dan tulis buku ni, dia tak rugi pun. Kalau you buat buku 60 page pun dah buku, 70 page pun buku, 100 page pun buku. So you start small and then it grows. Jangan tiba-tiba nak buat buku, nak terus buat 200 pages. Then you get demotivated. You will stop at certain value of death, you know. Sama dengan produk life cycle, you buat innovation. Nanti I nak tanya Sivarao juga kalau sempat. Because he did a lot of innovations. But now the culture is you need to commercialize. So where are we now? When I ask Proji, zero, still zero. Tak boleh. Buat banyak, profesor pun ramai. Profesor yang ada datang hari ni, you kena buat something. Tolong adik-adik. Tolong yang lain. Kena kembangkan. Sebab commercialization, not necessary you jual produk tu. It can couple with your services. Mungkin the tool you come with service. Do consultation. That's also commercialization. Sebab saya tahu kat sini ramai yang hebat-hebat. Saya harap semua start buat. Jangan tunggu sampai hujung. Bila nak kerja naik pangkat tu baru nak buat. Bila tu you akan rasa lelah tau. Sebab sebenarnya saya nak share experience saya. Benda ni akan datang sekali kalau you buat kerja you as academics. And you sincere and passion with what you are doing. Dan bila cukup tempoh, you kumpul-kumpul, oh cukup markah pun. Tapi you kena buat. Start. You tak ada orang kata one day yang you tidur. Memanglah kita tidur hari-hari kan. Maksud saya yang you tak nak buat. Memang kita ada dekat life cycle tu ada satu tempoh yang mungkin kita akan sedih. Kita akan give up. Kita akan rasa lelah sebab dengan banyak-banyak hal yang berlaku. Tapi that is the learning process. Sebab itu yang I say the maturity level. Kalau you tak ada proses itu, you won't be mature. Dan macam contoh buat grant. Janganlah marah Proji bila tak dapat grant. Because you have to go through the process. You have to go and pitch. You have to do the proposals. Then you need to face all these people. Memang sometimes kita geram kan, sebab kita rasa kita yang terbaik di dunia contohnya. Pernah ada satu session saya attend. Dekat saya ingat lagi. I don't know whether your area or zaman Datuk Jai. I rasa FKMP or FKP juga. Dia jawab, sebab saya yang terbaik di dunia. Itu zaman waris kot, waris Timbalan Mengaraki. So saya kan masa tu saya panel. Saya macam nak ketawa ke, aku nak marah ke apa ni. Tapi nak cakapnya, if you are confident to spell out you are yang terbaik di dunia, you prove it to the UTM. You prove to us you are yang terbaik di dunia. Kalau yang terbaik di dunia, mesti you yang terbaik dekat UTM. Betul tak? So, saya nak nampak lah, adalah staff kita. Saya nak berbangga dengan, sebab kita punya niche is advanced manufacturing technology and computing technology. So, I'm looking forward FTKIP to have one product yang you commercial, yang you akan ada satu hari yang Perdana Menteri launch your product here. Dekat Dewan ni contohnya. Then, Hambali, you can be proud that you are the dean yang dapat motivate any researchers to do this, to make FTKIP to the next level. And then you make all of us proud that you make UTM to another level. So I really hope the professor talk is not for just for Sivarao to share his experience, his journey, his areas, but for all of us to learn what should we do as what should we be responsible with. Sebab saya nampak banyak kita ni ramai lecturer kita 70% 41 and below. 41 years old and below. Sepatutnya kita ni dynamic. Kita ni agresif. Kita ni masih ada desire yang tinggi untuk berjaya sebab kita nak hidup atau kita nak service another 20 years. At least 20 years Kalau yang umur yang lagi muda, FTK pun ada staff-staff yang dari FTK mungkin lagi muda 30-an, 20-an. So you have another 30 years of service. Patut journey tu sangat lama lagi. Tapi kalau kita pada umur yang 40-an ni, kita nak kerja macam orang 60-an, tunggu pencen, then we should be ashamed of Prof Rom. Sebab Prof Rom dah pencen pun dia nak datang kerja lagi. With his medical condition pun he still wants to work. So we need to be ashamed of ourselves. Where are we? Not to be early, to be satisfied with what we achieve. I'm still not satisfied with what I achieve now. Because when kita dalam Islam memang kita kena bersyukur dengan apa kita dapat, tapi kita kena selalu berusaha untuk dapat yang lebih baik. Saya tak pandai cakap panjang-panjang sangat tapi I hope lah you all can get me what I said, because you are the jantung, you are the nadi of UTM. You all ni semua. Kalau you all tak buat kerja you sebagai researchers, you tak buat kerja sebagai academics, you tak akan dapat bantu TNC untuk capai KPI. Okay, saya harap today I will give you one information. I think this is a first hand information. Semalam punya meeting Kita perlu increase our postgraduate numbers. Currently kita baru dalam 1% kot daripada target yang kita dapat. You imagine 1%? 1% saja. So, in order to help UTM, in order to help all of you as well to get a postgraduate students, so UTM has agreed to come out with one fees, satu fees yang kita boleh guna untuk semua course. So tak ada lagi macam offshore berapa fees ni berapa. No, we will give a standard fees, and each of us who can bring one student will get 5,000 ringgit. Satu bawa satu 5,000 So kalau seorang, kalau hari raya nak sampai ni bulan 3, you pergi cari 5 orang, dah 25,000. Kalau yang ada nak tambah cawangan lelaki, you nak cari 50,000, you cari 10 orang. Contohnya. No, this is serious, no jokes. We're going to finalize it in Senate, this coming Senate, about this pricing. So during my amanat, I will give this information and you can start promoting from now. So SPS, TNCs, TNCA semua dah kena ada team lah. So fakulti saya harap saya akan panggil dekan-dekan, create marketing team. Siapa yang nak buat marketing ni, duduk dengan dekan. Macam mana nak promote fakulti masing-masing, how to get the students. But you are allowed also to promote other faculties, not necessarily FTKIP. So this is a first hand information come from yesterday's meeting. So we have decided that. So we will give each and everyone, not only academics even yang PJ, yang technicians ke, apa ke, admin ke, kalau you pun boleh bawa student masuk, you will get 5,000 ringgit. So saya harap kalau kita ada 2,000 staff, satu bawa satu, kita akan ada 2,000 students. Dan dia tak tertakluk kepada postgrad saja, it also opens to the open access undergraduates. Open access ni maksudnya dia laluan terbuka, dia tak melalui UPU, tapi dia kena bayar full fees. So you can go for that direction. Lepas ni semua orang boleh promote. So setiap bulan hantar satu. So kalau setiap orang buat, kalau dari FTKIP ada berapa staff? Probably 174. So dari sini kita akan 174 student. So kalau bayangkan FTMK ada 100, you ada 100, kita ada 500. Tapi kita perlukan 5,000 sebenarnya. Dan Prozol target semalam saya tengok yuran pun seseram, dia nak 3,000. Tapi kalau everyone can do it, everyone can bring 2 students, we have 2,000 staff, we manage. So anyone can take it, do it. You can do internationally, you can do locally, you can go to industries, go. But do not jeopardize or tolerate on your teaching and learning hours. You boleh pergi, tapi after your time. So maksudnya dah minta kelulusan daripada ketua PTJ. Maksud saya keluar dengan berikut lah. Jangan keluar saja nanti apa-apa berlaku tengah jalan. Sebabnya tak tahu, you pergi promote reject student. So this is the way forward that university is supporting our staff, is incentivize our staff. Actually this idea, I want to credit Prof Rom juga sebenarnya. Because I still remember, semalam saya share dalam meeting, idea ni berjaya masa kumpulan research saya buat bengkel buku, writing books. So he said in UM, referral ni kan, incentivize the referral ni dah berlaku. So we start with one member bring another member, you get RM75. And in 3 days, our bengkel buku full house. So that I think we can practice in bringing student into UTEP. But we give a bigger amount with RM5,000. I hope all of you will grab this. Jadilah, masuk jangan dengki-dengki. Siapa nak, lepas ni tak ada siapa nak buat pesisir, nak ada report SPRM, tak ada, tak payah. Sebab sendiri you ni boleh pergi cari. You pergi jumpa PPSH atau you pergi jumpa UHE, you dapat RM5,000. Kalau you rajin, setahun you cari 100, you ada RM500,000. Sebab konsep saya cakap dekat meeting semalam, UTEM kaya, staff saya pun kaya. Okay? Itu dia. So tak ada. So lepas ni tak adalah yang cucuk-cucuk nak pergi SPRM, pergi report prozol apa semua. Okay? Sebab semua buat. No, I'm telling this because we are academic. We need to cultivate, we need to culture this. Dan satu lagi pada saya is hard effort to promote students. I know how hard to bring students. It's not easy. It's not easy. So same goes to professors. Profesor yang ada kat sini, you pergi keluar, pergi promote. Sebab you cakap orang confidence. UTEM ni memang bagus, UTEM is TVET number 1. You must cakap. You promote them to come. So, but we, last time we ask you to promote, without nothing kan, tak ada apa, you cuma bantu. Sekarang, kita incentivize. Kita bagi you. So, kalau you create team, you share lah in your team. Saya galakkan you buat dalam team lah. Dalam team lebih senang. Tapi dalam masa sama, jangan lupa dah sibuk sangat cari student, you lupa buat research. You lupa ganti ACPI. You dah tak kisah dah buat grant. Sebabnya research. Okay, ni I cakap, kena buat juga. Okay, yang itu is sampingan. I tak nak you pinjam along ke apa. You pergi cek student, you dapat RM5,000. Okay, jadi sama dengan kita tak payah nak harap-harapkan duit RM2,000 yang PM nak bagi tu. You kalau cari student, you dapat RM5,000. Kalau 2, RM10,000. Like I said, 10, RM50,000. One semester you find 10, you get RM50,000. We have 2 semesters, you know. We can get RM100,000. Lebih daripada gaji profesor. Don't worry. Okay, saya dah macam banyak pula cakap kan. Patut saya kena cakap pasal Sivarao ni. But actually I know Siva for long. No doubt about his capability, especially in innovation. And I really hope, Prof Siva, after this, you will help and mentor more to be better than you. Kita semua tak nak jadi macam kita, kita nak be better than us. Macam saya sebenarnya minta MPU dah lama buat satu skim mentorship ni. Satu profesor mentor 5 PM and 5 senior lecturer. So that dari situ saya boleh evaluate the KPI and KPI profesor secara objektif. Sebab semua profesor ni saya yang bagi SKT tau. Bukan dekat. So sometimes I need more objective punya evaluations. So what you have done. So actually I need this. MPU please. Saya tak tahulah MPU ni macam mana. Saya rasa tak ada orang muda dah duduk situ. Saya harap lebih dinamik. Dan mungkin kita kena ada meeting selalu untuk make this happen. Okay, and Prof Siva, once again, congratulations. It's not easy to come to this day to do your professorial talk. And wish you all the best. Thank you. Assalamualaikum.
Terima kasih. Dimohon agar Mac Chancellor untuk kekal di atas pentas bagi sesi penyampaian cenderamata. Terima kasih. Dijemput ke semua diri kehormat untuk naik ke atas pentas bagi sesi penyampaian cenderamata. Dipersilakan. Majlis dengan segala hormatnya menjemput Yang Berbahagia Naib Chancellor untuk menyampaikan cenderamata kepada Yang Diraikan, Prof. Sivarao. Terima kasih bagi Naib Chancellor. Seterusnya majlis menjemput Yang Berusaha Prof. Amali Arif, Dekan FTKIP untuk menyampaikan cenderamata kepada Yang Berbahagia Datuk Naib Chancellor. Terima kasih Prof. Amali, dan juga terima kasih kepada Yang Bagi Naib Chancellor dan ke semua dirjen kehormat. Selesai sudah bahagian pertama majlis kita pada hari ini. Dijemput dirjen kehormat untuk ke acara seterusnya. Majlis diteruskan dengan jemputan Yang Berusaha Prof. Amali Arif, Dekan FTKIP untuk menyampaikan pengenalan ringkas mengenai Profesor Engineer Teknologis Dr. Sivarao Subramanian. Dipersilakan Prof.
Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma shalli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Assalamualaikum warahmatullahi wabarakatuh. Dan salam sejahtera. Salam pagi Jumaat dengan penuh keberkatan dan dilimpahi rahmat dari Allah Subhanahu wa taala. Yang Berusaha Profesor Dr. Zulkifli bin Ibrahim, Timbalan Naib Chancellor Akademi dan Antarabangsa Universiti Teknikal Malaysia Melaka. Yang Berusaha Profesor Engineer Teknologi Dr. Ghazali bin Umar, Timbalan Naib Chancellor Pendidikan dan Inovasi Universiti Teknikal Malaysia Melaka. Yang Berbahagia Profesor Madya Datuk Dr. Sabri bin Muhammad Sharif, Timbalan Naib Chancellor Hal Ehwal Pelajar dan Alumni Universiti Teknikal Malaysia Melaka. Yang diraih Profesor Engineer Teknologi Dr. Sivarao Subramanian, Profesor di Fakulti Teknologi Kejuruteraan Industri dan Pembuatan FTK. Pegawai-pegawai kanan UTM, warga akademia UTM, para pelajar, tuan-tuan, puan-puan yang saya hormati sekalian. Dengan hati yang tulus ikhlas, saya ingin menzahirkan ucapan terima kasih dan selamat datang kepada para hadirin dan hadirat ke majlis syarahan Perdana Profesor bagi sahabat fakulti kami yang diraihkan, iaitu Profesor Insinyur Teknologi Dr. Sivarao ajuran bersama FTKIP dan KAIS pada tarikh keramat hari ini 24 November 2023. Izinkan saya mengungkapkan serangkap pantun sebagai madah pembuka bicara. Seterusnya memperkenalkan kepada semua Profesor Insinyur Teknologi Dr. Sivarao atau lebih dekat di hati kami sebagai Prof Siva. Sebelum sisi Syarahan, Perdana beliau dimuliakan. Terbang helang di tinggi awan menjulang, hiasan melati bersulam kiambang. Profesor terbilang, FTK gah dan cemerlang, gemilang universiti amanah terus menyumbang. Begitulah bagai dikata, Profesor Insinyur Teknologi Dr. Sivarao telah berkhidmat di UTM selama 21 tahun, kira-kira seusia dengan 2 dekad penubuhan fakulti dan universiti. Beliau adalah seorang profesor dalam bidang kejuruteraan reka bentuk inovatif. Beliau turut merupakan seorang jurutera bertauliah yang berkompeten dalam bidang kejuruteraan mekanikal dan perbuatan. Sepanjang tempoh perkhidmatan beliau di UTM, beliau pernah dilantik sebagai Timbalan Penggarah di Pusat Pengurusan Penyelidikan dan Inovasi (KRIM) sebelum dilantik sebagai Penggarah yang pertama buat julung kalinya di Pusat Inovasi Pengkomersialan CIC UTM. Pada khidmat saya, kepimpinan beliau sewaktu di CIC dalam membudayakan inovasi berimpak tinggi, harta intelek dan pemindahan teknologi ke UTM yang kita cintai ini telah menjalinkan ikatan erat universiti ini dengan pihak industri dan pemegang taruh yang lainnya. Mengiktiraf kepakaran beliau dalam pendidikan berteraskan aplikasi industri, sebagai dekan fakulti, saya lebih mengenali beliau sebagai seorang pendidik yang aktif dalam bidang reka bentuk inovasi dan pemodelan proses yang melibatkan aplikasi kepintaran buatan dalam bidang kejuruteraan, mekanikal dan perbuatan termaju. Antara kejayaan Prof Siva yang tidak dapat kita ragukan adalah keupayaan beliau dalam menerbitkan lebih daripada 200 penerbitan saintifik berindeks yang berimpak tinggi, mengetahui lebih daripada 60 geran penyelidikan dengan dana kumulatif sebanyak 3 juta ringgit Malaysia dan menjadikan perunding kepada lebih daripada 30 projek perundingan luar. Sehingga kini, Prof Siva telah berjaya menyelia lebih daripada 20 tesis ijazah tinggi sarjana dan doktor falsafah. Seterusnya, kehebatan Prof Siva dalam bidang inovasi telah turut dibuktikan dengan pencapaian pemilikan lebih daripada 20 harta intelek dalam berbentuk paten reka bentuk industri, hak cipta dan tanda dagangan, yang mana ada beberapa harta intelek beliau telah berjaya dikomersialkan. Kepakaran beliau turut diiktiraf bila mana Prof Siva telah dijemput untuk menyampaikan pengkongsian perhubungan penyelidikan dan inovasi di lebih 50 persidangan antarabangsa dan kebangsaan. Prof Siva yang kita kenali turut aktif menyumbang di peringkat nasional sebagai panel penilai bagi dana penyelidikan awam dan swasta, termasuk kementerian dan agensi luar. Sebagai jurutera profesional di FTKIP, beliau turut menyumbang kepada negara sebagai panel penilai akreditasi program kejuruteraan bagi khusus ijazah sarjana muda dan diploma di institusi luar, di samping aktif dalam memberi input dan buah fikiran kepada kelestarian program akademik yang ditawarkan di peringkat fakulti dan UTM sebagai salah seorang panel penilai dalaman. Prof Siva kekuatan kami di fakulti yang merupakan peneraju kepakaran dalam bidang inovasi yang diiktiraf sebagai Competent Technology Transfer Professional ataupun ATTP di UK, telah membangunkan modul-modul latihan yang berupaya mencetus idea-idea inovatif di kalangan penyelidik yang dapat dijadikan panduan dalam memimpin mereka untuk menukarkan idea-idea kepada hasil penyelidikan yang berimpak tinggi dan penyelesaian efektif dengan menggunakan strategi unik dan keadaan yang sistematik, dan juga sangat berdedikasi dalam mempertingkatkan nilai inovasi secara pemikiran terkehadapan ke arah merealisasikan penyelesaian bersifat ketara. Prof. Siva, seorang yang mudah didekati, merendah diri, tidak lokek berkongsi ilmu dan sentiasa ceria bersama kami di kalangan warga fakulti. Pribadi beliau, Prof. Siva, sangatlah disenangi oleh kami semua. Beliau merupakan seorang yang berpandangan jauh, inovator di fakulti dan sentiasa bertekad menginspirasikan penyelidik-penyelidik muda agar sentiasa merangkaikan teori dalam aplikasi praktikal dan penggunaan bagi setiap pencapaian yang berfaedah kepada akademia dan industri. Hasrat saya agar Prof. Siva dapat terus memberi inspirasi kepada kami semua di fakulti dan sentiasa berkongsi buah fikiran agar kami semua dapat mengikuti jejak langkah kejayaan Prof. Siva pada masa nanti, insya-Allah. Sekian, wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Marilah kita sama-sama menyaksikan sebuah tayangan montaj yang telah dibuat oleh pihak Rustia.
Saya Sivarao Syarahan, lahir di Teluntan, Perak, di satu tempat namakan Pekanbaru. Jadi saya lahir pada 26 September 1998. Pendidikan awal saya ialah di Sekolah Menengah Kebangsaan Sultan Abdul Aziz Teluntan, dan saya sambung ke Sekolah Menengah Kebangsaan Sultan Aziz. Dan pada tahun 1984 saya bergerak ke Ipoh, belajar di Sekolah Menengah Teknik Ipoh. Dan seterusnya pada tahun 86 saya mula pengajian saya di Politeknik Koma dalam jurusan otomotif diesel. Jadi 2 tahun mengaji di sana, dan kemudian saya sambung pengajian saya seterusnya ke Universiti Teknologi Malaysia Skudai. Jadi batch pertama di Skudai lah. Jadi di situ saya mengambil jurusan mechanical engineering. Kemudian selepas pengajian saya di situ, saya berhasrat untuk sambung master. Malangnya halfway through, supervisor saya meninggal, Profesor Ramzan, arwah Profesor Ramzan Mainal. Kemudian saya, yang itu ialah on multi-purpose hull design, on marine engineering. Jadi selepas itu saya diserahkan ke Lotus Car Design Analysis di bawah Profesor Kamal Azam. Tapi yang itu terjejas juga hasrat saya kerana berlaku gangguan pada geran penyelidikan. Jadi saya berhenti di situ, dan kemudian sambung master setelah berkhidmat dengan UTM pada tahun 2005 di MMU Melaka. Kemudian untuk PhD saya cuba sekali lagi di UTM di bawah Profesor Visi Venkatesh, dan beliau pula terpaksa dipindahkan ke MMU, dan saya sambung PhD saya di MMU di bawah supervision Profesor daripada Jerman lah, Profesor Peter Berwin daripada Jerman. Dan saya banyak belajar daripada beliau sebenarnya. Jadi sebenarnya pengajian PhD itu sebenarnya menjadikan saya sangat kritikal, dan sangat banyak saya belajar kerana PhD saya melibatkan projek dari industri di Surabaya di bawah pimpinan Profesor Peter Berwin. Itu sedikit sebanyak mengenai pengajian saya dari sekolah rendah sampai ke PhD. Okey, kalau nak tanya pasal PhD ni memang sangat detail lah. Sebelum itu saya bukanlah seorang yang sangat kritikal. Saya memang teknikal tapi tak berapa kritikal. Tapi saya belajar satu perkara yang sangat penting di bawah pendidikan Prof. Peter Berwin sebenarnya. Mereka tak banyak bercakap, tetapi mereka taruh hal itu. Jadi projek ini sebenarnya ialah projek konsultansi beliau, dan saya pada ketika itu ada 5 orang supervisor. Jadi yang pertamanya is main supervisor Profesor Peter Berwin, yang kedua is Profesor Nabil dari Pakistan, profesor saya ikut beliau, dan advisor saya ialah Visi Venkatesh, Profesor Visi Venkatesh dari UTM, dan saya ada 2 orang Indonesian industrial supervisor di Indonesia Surabaya. Jadi pengalaman tu memang susah lah macam nak cerita, tapi saya banyak belajar sebab being mechanical guy, and tajuknya ialah kisah berkaitan dengan predictive modeling of AI modeling untuk laser machining. Tapi alhamdulillah projeknya selesai dan saya juga berjaya publish beberapa paper di peringkat PhD. Sebaik saya selesai pengajian di Politeknik Poma pada tahun 88, saya ditawarkan untuk mengajar di situ. Jadi selepas mengajar sekejap, saya berhenti. Saya masuk ke industri dan juga sama belajar sekejap. Kemudian selepas pengajian, saya masuk balik ke sistem Politeknik. Jadi masuk balik sistem Politeknik, saya mengajar di situ selama 12 tahun setengah lah saya bersama Politeknik. 3 Politeknik Premier yang saya mengajar, iaitu pertamanya Politeknik Diploma di Ipoh, Politeknik Shah Alam di Shah Alam, Selangor, dan Politeknik Johor Bahru. Barangkali namanya dah terkalah sekarang. Jadi di Johor Bahru saya orang nombor 2 lah. Jadi sebenarnya banyak pengalaman yang ditimba semasa di Politeknik Johor Bahru sebenarnya. Ini soalan yang agak mencabar. Nak kata saya terbaik tu mungkin tidak. Kalau kita tengok sekarang ni ramai lagi yang muda-muda lagi dah mencapai tahap yang sangat bagus. Jadi saya jejak kaki ke UTM ni agak lewat sikit. Selepas berpengalaman lebih kurang 12 tahun baru jejak ke sini. Jadi bila jejak ke sini, pada ketika itu saya tak tahu sama ada nak kata it's by chance or it's by design. But it happens naturally. So mungkin sebab saya buat sesuatu yang saya suka dan ianya terjajar dengan aspirasi dan kemungkinan. Jadi itu menunjukkan itu merupakan satu titik tolak lah. Kenapa saya driven to do more and more until I'm involved dalam banyak perkara. Secara tak langsung ianya juga mencapai KPI yang sepatutnya. Menyentuh perkara itu sebenarnya peranan seorang profesor tidak habis di sini. Saya rasa kita semua tahu perkara yang ini. Sebenarnya banyak yang saya sekarang kalau dilihat selain daripada my core mechanical and manufacturing punya disiplin, saya terlibat banyak secara langsung dan juga tak langsung on the innovation development. Jadi saya banyak menjadi consultant on the innovation aspect, contohnya kepada PPR, untuk trader, untuk banyak organisasi yang saya terlibat untuk memberi tunjuk ajar ataupun untuk memperbaiki ekosistem mereka dalam untuk mempergiatkan lagi inovasi. Begitu juga contohnya saya ke Indonesia untuk advise mereka on what to do and what not to do on technology transfer office development. Macam tu juga dengan UC, University Medical Technical, saya menjadi konsultan mereka. Jadi banyak lagi JKR contohnya, saya mendapat peluang untuk membantu mereka dalam membangunkan ICM, Innovation Competency Model Dictionary. Banyak juga lah yang melakukan presentation yang saya. Jadi saya bangga sebenarnya bukan kerana diri saya, tetapi kerana dapat membawa UTM ini ke masyarakat luar. Maknanya bila saya pergi itu, saya membawa nama UTM. Jadi begitu juga saya dijemput sebagai keynote speaker di Berlin, Germany, dan juga baru-baru ini di Brunei. Jadi saya rasa saya membawa nama UTM ke pesada antarabangsa sebagai satu peranan lah, sebagai seorang profesor, selain daripada melaksanakan tugas ideologi yang besar. Sebenarnya sebagai tipikal akademik, kita memang jangka macam tu. Tetapi mungkin saya ni agak bertuah. Sebab saya pernah bekerja di industri. Saya pernah bekerja dengan Motorola Malaysia di Sungai Wing, long back, in MBA final test. Jadi yang itu banyak membantu. Selain itu saya juga pernah bekerja untuk tempoh yang agak panjang dengan TMIG, syarikat Jepun. Jadi sebenarnya selain daripada yang industri lain yang tempoh yang singkat, dua industri ini tempoh yang agak panjang. Dia sebenarnya memberi pendedahan kepada kita what do they think and how should we tackle them. So itu sebenarnya satu titik tolak kepada saya, dan saya tidak rasa takut untuk speak their language. So mungkin itu satu perkara yang positif lah yang saya lihat. Jadi mungkin itu gambarnya. Saya tidak rasa kekok untuk mendekatkan diri saya dengan industri, dan kita tahu apa yang mereka expect dan apa yang kita boleh expect dari mereka. Mengajar bukan mengikut textbook ataupun sukatan pelajaran yang kurikulum yang telah disetkan. Saya suka bawa pengalaman industri saya, pengalaman konsultansi saya, bawa ke classroom and kita relate dengan the curriculum. Jadi secara tak langsung, saya suka dedahkan pelajar ini bukan into the confined classroom unit. So saya suka bawa dia berhijrah keluar, bagi dia case studies yang melibatkan something yang very relevant dengan that subject matter. Selalu kita mendengar bahawa kita melihat ada perkara-perkara yang mungkin kita tak nampak lagi. Apa sebenarnya skill ataupun knowledge yang terselindung daripada yang kita lihat. Jadi mungkin kita boleh cuba. Dia ada satu proverb yang dia kata, tap the least of the best and be the best of the least you could. Always cuba lawan arus. Maksud lawan arus, jangan selalu kita suka buat benda yang kita nak dengan in a very soft. Hanya lawan arus maksud saya, kalau kita belajar lawan arus, kita menguatkan diri kita. Jadi untuk berenang mengikut arus tidak akan menjadi satu benda yang susah. Benda yang susah itulah sebenarnya akan menghasilkan hasil yang baik. Jadi saya sarankan kepada masyarakat muda, segeralah jadi profesor dan sumbanglah kepada negara dan juga industri. Kalau tak, apa lagi peranan?
Kini tibalah kita di kemuncak acara majlis, iaitu syarahan perdana oleh Yang Berusaha Profesor Insinyur Teknologi Dr. Sivarao Subramanian. Majlis dengan segala hormatnya mempersilakan Yang Berusaha yang diraihkan Profesor Insinyur Teknologi Dr. Sivarao Subramanian untuk menyampaikan syarahan beliau yang bertajuk Tier 5.0 Advancements Toward Economical Driving and Saving Lives. Silakan Prof.
Yang Berusaha Profesor Dr. Zulkifli bin Ibrahim, Timbalan Chancellor Akademik dan Antarabangsa Universiti Teknikal Malaysia Melaka. Yang Berusaha Profesor Insinyur Teknologis Dr. Ghazali bin Omar, Timbalan Naib Chancellor Penyelidikan dan Inovasi Universiti Teknikal Malaysia Melaka. Yang berbahagia Profesor Madya Datuk Dr. Sabri bin Muhammad Sharif, Timbalan Naib Chancellor Ahal Ehwal Pelajar dan Alumni Universiti Teknikal Malaysia Melaka. Yang Berusaha Profesor Insinyur Teknologis Dr. Hambali bin Arif, Dekan Fakulti Teknologi dan Kejuruteraan Industri dan Pembuatan Universiti Teknikal Malaysia Melaka. Prof Zaki, Prof Rom, para pegawai kanan UTM, warga akademik UTM, para pegawai serta kaki tangan sokongan, para pelajar, tuan-tuan, puan-puan dan seluruh warga FTKIP yang saya hormati sekalian. Salam Jumaat, selamat pagi dan semoga kalian semua sehat walafiat. Terlebih dahulu saya ingin mengucapkan jutaan terima kasih kepada semua ahli jawatan kuasa program ini yang begitu komited dalam mengaturkan majlis yang sebegitu indah dan bersejarah bagi diri saya. Terima kasih FTKIP. Sebelum memulakan syarahan, saya memohon izin untuk menggunakan dua bahasa secara selang-seli bagi keberkesanan serta keselesaan komunikasi yang lebih mesra. Untuk makluman, kandungan syarahan ini akan dimulakan dengan latar belakang bagi memahamkan keperluan fundamental sebelum diteruskan dengan dapatan longitudinal research berkaitan teknologi tayar yang telah saya jalankan. Oleh itu, saya dengan rendah diri ingin memohon kepada para hadirin agar dapat bersama-sama saya di pagi Jumaat yang indah ini rilekskan diri, mendengar syarahan hingga selesai. Saya pasti kalau bukan knowledge yang dibawa keluar nanti, at least information sudah pasti. Disebabkan dekan tadi mulakan dengan pantun, saya rasa saya perlu juga mulakan dengan pantun. Malam tadi baru dapat. Kereta F1 tayarnya botak, bukan bermaksud kurang cengkaman. Ilmu tayar di dalam otak dengan tuan-puan saya kongsikan. Bila pakai bonnet, pakai macam ni kan, benda nak keluar pun tak boleh keluar. Jadi saya kalau boleh saya minta saya santai-santai sikit. Saya masa kahwin pun tak takut macam ni. Jadi menggigil pun ada bila pakai macam ni. So saya minta izin saya teruskan dengan presentation saya. Jadi ini seperti kata Dato' MC, hadiran kita kurang. Mungkin kita beranggapan positif, mereka ada kuliah, ada kekurangan masa untuk hadir. Walau bagaimanapun saya mohon apa yang kita dapat hari ini dapat dikongsikan bersama untuk kebaikan. Ya. Persoalan yang pertama adalah, have you ever worried about the tire pressure? Good. Do you know the benefits and drawbacks of tire pressure? And third one is, how frequent do you inflate your tires? And fourth one is, have you faced any problems at home because of tire pressure? I do not know about yourself, but I have learned from number 1 until number 3 because of number 4. Let me share you honestly what actually happened and what transpired me to be in the field of what I'm going to speak to you today. Bagi sesiapa yang pasangan yang intim, cuba tanya soalan ini kepada isteri anda. Why didn't you inflate the tire? And this one question has made me to sleep alone for a few nights. Because it creates spark between me and my wife. Alasan yang diberikan ialah, I don't know the value to sell. Saya pasti ada di kalangan tuan-tuan puan-puan yang mendengar daripada isteri ataupun ada di kalangan hadirin sendiri pernah cakap macam ni. Yang kedua, I don't remember the value. Yang ketiga, too many people at air kiosk. Takkan saya nak tunggu, nak pump. And the last one, the kiosk was malfunction. Saya pergi, dia rosak, nak buat macam mana? So dia tak pump. So, how do I solve this issue? I always think that when there is a problem, you must find a way to solve the problem. Okay? So solving a problem without being into it is a problem. So how do I solve my family problem due to tire pressure? Masa tu saya tak fikir pasal research pun. Macam mana saya nak solve my always quarreling because of this? So saya cuba mendalami sedikit berkenaan dengan tayar. Saya tahu sebelum itu is about if the tires are well inflated, my steering is light, the car is light, and I feel nice to drive. That's the only thing that I know about. But unfortunately, bila saya go deeper, I found that giant industries that related with tires reveals that 80% of the vehicles on the road are running with improper tire pressure, which I believe most of us didn't know about this. Going further, I found that most tire explosions are caused by tires running with improper pressure, which brings to major road accidents. This is even sad. So, anggapan saya, if I can gather this information, I can educate my wife to be more sensitive of how or why the tires has to be properly inflated. But the bigger fact is, this is a fact. In USA alone, there are approximately 78,000 crashes related to tire blowouts every year. Apalagi Malaysia. Saya cuba mencari data di Malaysia, tapi tak ada. We do not have enough data on this. Probably we are not sensitive of this matter yet. Further, about 400 fatalities annually attributed to these accidents, and most of these accidents occur while driving on highways. Now, the multiple studies shows that a ground vehicle which travels at 70 km per hour, only 70 km per hour, you need not to go 110. Explosion of any of its tire would cause catastrophic failure, leading into a major road accident, and in most cases, it kills almost all inside. So this is very sad. This is very, very sad. So what do we do? Therefore, today I'm going to share with you my journey with my team on how we arrived into the Tire 5.0 technology, where it is expected to advance towards economical driving and saving life. So I'm Sivarao today with you from Faculty of Engineering and Technology, Industrial and Manufacturing. So what is tire? All we know tire is a black rubbery, correct? Most of us, that's what we think. So believe me, we are all wrong. Tire is defined. The word tire has been coined from English word called attire. Attire, meaning clothing or apparel. Attire was originally a hoop of metal fitted around the rim. So even a metal is called tire. To strengthen it and improve its durability. So kalau kita kata tayar ni mesti getah dan sebagainya, maknanya kita belum betul lagi. So let me very quickly show to you the primary parts of a tire. So the first thing is the sidewall, which is this, and second is the tread, belt, inner liner, and bit. So what is this sidewall for? Sidewall is basically to absorb the energy, impact energy. So it is very, very important, and that we can see how sports cars are modified with a very tiny sidewall. Second one is the tread. We know it's very important as a friction surface to the ground. And the third one is the belt, where the belt is the inner structure to strengthen the tire. And the inner liner is also important. I've worked on that as well, but I'm not going to share here. This is because to prevent or to reduce the permeability, meaning to say the air escapism from the tire compartment to the outside air. And the last but not least is the bead, which strongly holds the tire to the rim. Now, throughout this, I will share about pneumatic tire and solving problems of pneumatic tire. So pneumatic tire means tire yang kita isi angin. Okay, any tires that, so pneumatic is angin. Now, do we really know how much is our car tire pressure? Most of us guess the value, or we refer to the value that is on the door frame, and we forget that when we change the tire, we still follow the same value. It may not be relevant anymore. And even you go to a tire shop, the same tire will be recommended with different pressure. Because why? We are not aware of the danger running cars with improperly inflated tires. We have all seen, to give a better picture, I will share this. We often go for a party, and after the party, 2 or 3 days or for a week, you will see what happened to the balloons. They deflate. And what is the mechanism that makes the deflation? We know the balloon deflate, and then we come back, that's it, finished. But have we ever thought why they deflate? It's a very simple principle that we have learned in probably primary or secondary school, where it says gas molecules are much smaller or finer than the solid molecules. So no matter how well they are taken care, no matter how expensive they are or how the tires still leak out 10 to 15 kilopascal of pressure every month. Every month, 10 to 15 kilopascal will be released out. So tires are silent killers. And the drop can never be observed easily by our naked eyes. So to quantify and make ourselves much relevant, I would put it this way. Loss of every 10 kilopascal is equivalent to adding 70 kilogram extra load. Okay, 70 kilogram extra load. Maksudnya, kalau sebulan kita tak pump, kita seolah-olah membawa kereta itu dengan 70 kilogram tambahan. So imagine if we don't inflate for 3 months, we are adding 210 kilogram additional load virtually. But we don't realize. That is why we say, kenapa kereta saya berat? Kenapa steering berat? We don't know it is because of the tire. Which means, a car with 5 passengers, when it is not inflated for 3 months, just 3 months, is now virtually carrying the load of 8 passengers. So kalau 3 bulan kita tak pam angin, kalau orang tanya kereta kita boleh naik berapa orang? 8 orang. Bukan lagi 5 orang. Right? So that much we are overloading our car. This is fact. This is not what I make. And all this I know after I venture go in. And only then this has come my niche. So let us share. I just wanted to share what improper tire pressure causes. The first thing first is greater tire wear. So when we run with improper tire pressure, there will be a greater tire wear. So that will cause for excessive tire disposal. So we are not towards green. And you know how the rubber materials are being produced, how much energy is being used for the tire production. And tire explosions, even greater or lower, tire explosions are very prone when the pressure is not appropriate. And major road accidents also reported due to improper tire pressure. And believe it or not, when we run without improperly inflated tires, it reduces the braking efficiency. So bila kita brake, mungkin dia jarak dia bawa tu lebih jauh berbanding dengan properly inflated. And overloading engine, where it increases the rolling force. And also it makes the steering much heavier and greater emission. It will increase the fuel consumption actually. Okay, you will see, if you don't realize, probably after this you will notice, the moment you feel the steering is heavy, and if you don't focus on your tires, you will see your fuel consumption will be greater. So when we are waiting for the subsidy or expecting from the subsidy from the government, actually we can subsidize ourselves. And all this ending up into a money wastage. So this is on the what is not good, right? Let's see what is the benefit we can get if we could run with a properly inflated tires. So Dunlop, Continental and Federal Motor Vehicle Safety Standard validated that properly inflated tires can actually save fuel 4 to 10%. It saves fuel 4 to 10%. Save tire life up to 20%, which is equivalent to 9 months. So for those who are regularly changing the tires, please look into your pressure. That could be one of the reasons. And the third, increase braking performance up to 20%. So your braking performance will be enhanced. Reduce tire puncture risk up to 50%. Sebelum saya buat this research, saya ingat lagi, kalau dulu orang tua kata, kalau tak ada angin, dia makan paku. Bahasa dia makan paku, tak ada angin. Okay, bukan kerana tayar lembut, dia akan termakan paku. So, the same thing here, that is why it's stated risk reduction of 50%. Lightens the steering system and ease self-steer. Maksudnya, bukan saja steering tu ringan, bila kita lepas, dia balik ke posisi asal, self-steer. It ease that as well. Reduce gas emission to the environment and ease motoring and reduce maintenance costs. They are all associated to one and another. And the most is reduce risk of road accidents. Therefore, in US, they have made mandatory, understanding the importance of tire pressure, US has made mandatory of using tire pressure monitoring system called TPMS. For those who are using high-end cars, Mercedes, BMW, Porsche and so on, I believe this is embedded in your car. And this tire pressure monitoring system has been enhanced and being widely used in most countries, including Malaysia. It is widely being accepted. Means you have a display and your display shows which tire, which pressure and so on. So that eases us. Okay? But still we don't bother. Knowing the defects, knowing the wastage, knowing the benefits that we may gain, but still we don't bother. Why? We lack the awareness about danger and benefits of tire pressure. Where the vehicle can still move, even with pressure reduced in tires. So we take things easily. Unless puncture, you've got no choice. If it's less, you don't even bother to look at the tires. How many of you every day look at tires? Forget about inflating. We don't even look at it. We know when the battery comes, it won't start, we won't move. We know when the fuel is not there, it won't start, we won't move. Right? But tires, you don't bother. It's just like after you marry 20 years, you don't see your wife every day in the morning. Right? You see in the office. And not realizing on how much tire pressure is associated with surface contact of the road, which directly influence the tire performance. So visualize this, the entire car load is supported only by 4 knife edge points. We are all from engineering background. If we draw the free body diagram, you know the entire car is actually resting on 4 knife edge counterloads. So imagine your entire car, your family in the car, and it is supported by only 4 knife edge supports. So what happens if one of the support gives way? That's where the major road accidents occur. So addressing the drawbacks and danger of running with improperly inflated tires and taking the benefits of running with properly inflated ones, the research roadmap drawn in year 2004. Believe me, at that juncture, we don't know what is the future. We simply draw. So that is why sometimes I believe that we should not be looking into perfection. And I learned through this. So we sit in a team and we draw this. And we can see here, let me explain very quickly. Year 1800, solid tires were introduced. Inflatable tires was in 1845. And therefore we come up with manual inflation in 1888. Okay, most of us use the term pump. I just want to emphasize here, the word pump is wrong. Because pump is only for incompressible fluid. Air is compressible, so we should not be calling it pump. So that is why it is called inflator. So kita tak kata saya nak pump angin. No, it's wrong. Okay, so I would want to inflate my tires, not pump my tires, because the medium is air, it is compressible. Okay. And then comes analog regulated inflation, and now we could see the digital regulated inflation in year 2000, around that area. When I was doing this, I was facing this issue because analog inflators. And therefore, in 2004, we come up with automatic tire pressure controller. You know, when you go to the kiosk, you don't know the value, right? So the kiosk is malfunctioned. So what do? So we were thinking, how could we come up with one device that you can basically inflate with anything, as long as you have got greater pressure. So we come up with this ATPC, where this is an intermediary part. From the kiosk goes to this ATPC, and from this ATPC goes to the tire. And the moment the tire is inflated with sufficient pressure, it will give hissing sound, and then you can stop inflating. Okay. And second, we design on tire pressure sustainability and automatic tire inflation, and eventually modular wheel. So these are the outcomes. So this is ATPC. So this has been patented and commercialized, and it was designed in the year 2004 to 2010. And this is tire pressure sustaining system, means this is, we are using, let me summarize just like this, so that later when you go to other slides, you can understand better. This is intermediary part, but still you need the kiosk, and still every month you need to inflate. So we were thinking, how could we make it so that you can inflate once a year? So we come up with this pressure chamber. So this pressure chamber is fit inside. I will show you later. And this device will take care of your tire pressure for the duration of 1 year. So instead of inflating every month, now you can just relax. You can inflate once a year. So you will never inflate the tire, but you will inflate this device. And then we thought, why do we go to the kiosk? Can we not to go at all? Then we come up with automatic tire inflating system. We developed automatic inflator. I will demonstrate later. Terima kasih, Prof. Okay, saya sambung. And while we were working on this, suddenly we faced some challenges. We were challenged by the airless tires. And we thought, how can we address this? And then we come up with modular airless tires. So let me explain in detail about this, my research project, first research project, which is automatic tire pressure controller. So this is the tire pressure controller. We have got preset values, and basically you can use with any inflators. You can use this, you can use this, you can use anything. So you need not to go to the kiosk, basically. So this device will take care of the pressure. So that the tire pressure on the kiosk can be set to almost any greater value. Of course, the value has to be greater than the tire. And ATPC takes care of the pressure required by the tire. And once pressure is sufficient, ATPC will alert the user by hissing sound. Research project 2 was tire pressure sustaining system, which I told you that it will last for a year. Now, we come up with this design. Basically, I believe there are postgraduates. I have mathematical models, analysis on how we actually come up with this. Unfortunately, we are unable to see. How you could see how mathematical models that you have 4 to 6 pages of derivation before you can even decide the design. So this is the chamber and fitting design. So we try to put a chamber inside the valley of the ring so that it can take care of the pressure. This is analysis, and this is how it's supposed to look like. However, referring to some standards and safety conformance, this is not approved. So we did not bring this further. Because if, if explosions happen to this chamber, it is equal or it's going to be worse than tire explosion itself. So therefore, this project has not been extended further. And then my research project 3, automatic tire inflating system. This is quite crucial. So basically, we plan for 4 stages. We would want to develop the concept and test rig development, and then we validate the compensation system, and we integrate the system with Perdana, and we validated the system with Perdana. So this is basically the sketch, a concept of the supply system. And this is the engineered tri-functional pressure compensating system. So beauty of pressure compensating system is, this one system can actually monitor the pressure inside the tire. It can open for inflating, and it can cut off through one single tube. So that is the beauty of this system. And this is the analysis that we have done. So it's an extensive job has been performed, and therefore it has taken a little longer. So we do the chamber fitting test for static and dynamic conditions. And these are the pressure chamber development stages. And you could see where we place this. Okay, so this is the system that I told to you just now. So we tend to come up with this, and we would want to put this chamber to the hub. This is the hub, this is the chamber, and this is a control system. So this control system will take care or transfer the pressure from here to the tire. And this is the one fabricated once. Okay, so this is the end product. This is the end product. And this is the product Perdana, and you could see how it is fit. So no modification is required on the car. It is just this system fit in here, and this one has to be fit to the inflating valve. So it will be automatically inflated. The moment the pressure in the tire drops, it will inflate. The moment the pressure drops, it will inflate. So for the duration of 1 year, you need not to inflate your tires. Right? So instead of asking the question again and again, why did not inflate, now you have that duration of 1 year to ask. Okay? Now, so designed as an accessory. So we designed this actually as an accessory. We want to put it in an accessory shop so that, okay, I want the system so you can just buy it and feed it according to the model. So based on the design and analysis, automatic tire inflating system is capable to sustain pressure up to 12 months for both static and dynamic conditions. Able to compensate pressure losses with the accuracy of 7 kilopascal or 1 psi. So research project 4, perpetual tire inflating system. So we were thinking, can we, without going to the kiosk, we come up with a plunger that can inflate this chamber. We had an idea. So we developed the concept and POC, and it worked. So assume this is a tire, this is the inflator. So we succeeded to come up with this project that can continuously inflate the chamber. So that is how we come up with. Unfortunately, in year 2000, about year 2000, early 2000, we found a competing technology called airless tires. Airless tires were investigated by giant tire manufacturers as well as many universities worldwide. So we know that they would want to go on, they want to overcome the problem of pneumatic tires. So how do we immediately encounter this? Before that, these are the structures of, let us understand the structure of airless tires. So if you look into the airless tires, they have some drawback. So this is what actually we managed to tap. Although they are so advanced, we looked into the gaps that where do we actually go in. So 2015 onwards, we can see the tires are going in and we found the gaps. What are the gaps? Most of them are made into one single piece with high-end materials, intrinsic architecture, and fully bonded mechanically. So this design's not only expensive and serves only higher-end group of people, but also requires higher maintenance costs and highly skilled personnel to have them fixed. So imagine if it's one single piece, intrinsic architecture, if any of the arm or the part gives way, the entire wheel you have to send for a repair. And after your repair, will the mechanical properties be the same as original? That's the question that we asked. Okay? And therefore, we tried to come up with a compensating technology, being the airless tire, but how could we supply to the competing technology? So we come up with compensating technology, which is called modular airless tire. So basically, we can see here, or we know, tire 1. You can see why is it called tire 5.0. And you can read the book, you may understand it better. Tire 1.0 is non-inflating, it's a metal strap. Tire 2.0 is tire mati, yang kita panggil tire mati, non-inflatable, right? Dead tire. Tire 3.0 is a pneumatic tire that most of us are currently using. And tire 4.0 is what airless tire is being flooded in the research as now. And what is tire 5.0 going to be? I don't know. We all came here to see what Sivarao going to talk about 5.0. Or he simply put 5.0 because now I are 4.0. Right? Whatever it is, I hope the information that or knowledge that I share with you will benefit in some ways. Alright? So let us see later. So basically, we would want to make a modular airless tire to overcome or to address the gaps of airless tire. So basically here we have 4 different themes. One, of course, we have to look into intermetallic hybrid hub, and we look into modular padding, and the most important is modular suspending system. So for modular suspending system itself, I've got 3 patents. And don't worry, I never use this money. Okay? I drafted on my own and I submitted on my own under university's name. Without any correction, it has been approved and they are granted. Okay? So if I say patent, then maybe we question, oh, we gonna do it university. Okay? So those were while I was in UCC then. So I drafted on my own. So I also learned skills of drafting then. And of course, we also study on the acceptance and impact study. We make a survey. We also publish paper on this aspect. We would want to know what are the conceptions or what they have in their mind, especially the public. Are they ready to accept airless tires, or are they scared with this structure? Right? Worse still when it is a modular. So these are the connections of all the sections that we have designed. And this is how basically the concept is of a modular airless tire. And exploded view of the modular airless tire. So we have cover, and this is the hub, this is the tire part. So those are modular. So we can remove module by module. Okay? And we have tested on a passenger's car, and it runs fine, but of course it is not perfect yet. And I would want to say you 10 or my team has to be proud about, because We are the first in the world who patented for modular airless tire. You can search, you can find. So we are the first one to coin the word modular airless tire. You can find now this concept has been applied onto lighter vehicles like bicycles and motorbikes. Unfortunately, we cannot sue them because we did not protect in their country. We only protected our IP in Malaysia. You see? So we cannot sue them, but we are proud that we are the brainchild of technology. Right? So we have tested this on this car, so maybe I don't have to show this. Of course, my PhD student worked on this. I'm glad. And this is the second version that we improved further, and we would want to see whether it can be used for off-road conditions. And we would want to see whether it can take up greater load on different structure of the vehicle. So we tested on the 4x4 vehicle. And this is what you will see the video. Basically, that's the concept, and this was developed based on the PRGS grant. And recently, I think most of you know that we were again given PRGS grant to further enhance this so that we can design a much robust modular airless tire for wider application. So the advantages of modular airless tire, it overrides whichever that I've mentioned before of the airless tires. So no more hassle of inflating tires, that's for sure. No more tire puncture problems, yes, certainly. Elimination of inflating equipment, so you don't have to purchase, probably there will be no manufacturing of inflating devices anymore. Or replace or repair only the defected module. Means if you have a module defect, you can just replace that module. And we are also looking into if they can subscribe into different sizes. I want to change my tire to, like, I want to go off-road for the same car, I can just change the modules. So it's going to be much user-friendly. Reduction in warehouse or storage space. So since they are modular, you don't have to store so many tires. So you have to store just few modules, which is in demand in your area. And of course, it is lower maintenance cost over airless tire. And medium-skilled maintenance personnel is sufficient to maintain. And wide range adaptability, vehicle type and wheel diameter can be applicable. Sustainable design, which is 70% of the tire material is reduced because of this design. So imagine just now you have got wall, right? You have got liner, you have got bead. So now you remove all this. So we are saving so much of energy in tire production, and we are towards green technology. So why is that tire 5.0 now? We call it tire 5.0 because this is very unique and first in the world, and this is a 5th version of the tire. Alright, I just want to mention this. Very limited to almost none of tire research in Malaysia is being conducted. We know Rubber Research Institute, they are more on the testing, they are using the rubbers, but we can take these wheels to test. RRI is being used to test the tires, but they don't do on the wheel as per se, as a total solution. Therefore, a lot more research potentials related to tire technology that I have reserved. Please take up. Let's embrace younger academics. It's worth exploring further, advancing tires, enhancing lives. Macam yang Dato' NC maklumkan tadi, kalau kita di FTKIP, I've got other ideas on the levitating technology. If we can together join hands, develop that technology and we can commercialize, then I think we can move forward. Okay? Hope we can together help our team. So I've come to the end of my lecture, and at this juncture, I'd like to thank to all past and present Vice Chancellors and Deputy Vice Chancellors, Deans and Deputy Deans of FKP, now FTKIP, colleagues across the campus, postgraduates and undergraduates, all friends and family who walked with me. And before I end, I'd like to, kalau kita mula dengan pantun, hujung pun kena pantun lah semuliknya. Okay? 8 tahun sudah profesor, tinggal 4 tahun untuk pensiun. Ayo jadikan UTM tersohor. Moga keserjanaan kita terus terjalin. Thank you.
Majlis merakamkan ucapan terima kasih kepada Prof. Sivarao di atas syarahan beliau tadi. Semoga hadirin sekalian memperoleh manfaat dan ilmu pengetahuan yang baru mengenai teknologi tayar terkini. Dari Kedah ke Pekansari, beli swasta di Kota Tinggi, selesai sudah tugas diberi, di lain masa bersua lagi. Dengan berakhirnya sesi syarahan itu tadi, maka berakhirlah sudah program syarahan perdana kita pada hari ini. Segala kekurangan yang berlaku sepanjang majlis ini berlangsung, kami memohon beribu kemaafan. Sebelum kita akhiri majlis, jadi dimohon untuk para hadirin untuk ke bahagian tengah Dewan untuk sesi bergambar secara ramai-ramai. Silakan.